Hi everyone, welcome to today's BIMCO Bites on Revit Formulae. Today we'll be going through the family editor to look at how to create different formulae, including the formula syntax, add, subtract, multiply, and divide functions, less than, greater than, equal to formula, and, or, and not statements, and finally, if statements, and bringing it all together. First up, I'm just going to go through some basic symbols and syntax for when you are creating formulae. Now, we're not going to go into the really in-depth ones today. We're just going to go through the basics. So first off, we've got parentheses, which is used to control group operations, just the same as you would in normal mathematical equations. So the things in brackets get done first. Of course, we've got addition, subtraction. Multiplication is the star symbol. So the rather than the X, division is the slash. Exponentation is the up arrow on the keyboard there. Equality is equals. Inequality, well, there isn't actually a symbol that you can use for this. So what you need to do is a not equation. So not X equals Y. So that's inequality. Greater than is the greater than symbol. Less than, the less than symbol. Greater or equal to. There is no equal to, like greater than or equal to function. So you have to then reverse it. So it would be not X is less than Y, for instance, in this case. Conditional statements is like if the condition, then return the value if it's true, or return this value if it's false with commas between. Then we have logical and or not. So and if both values are true, or if one of the values is true, and not if the value is not true, or multiple values. These are what we'll be going through today. Okay, we're going to head over into a family environment here. We've got a basic bathroom layout. We're going to mostly be operating out of the family types dialog here, but just to show you what this looks like, we have a bath on the left here. We've got a couple of baths that will turn on and off. We've got bath 1 and 2. We've got a couple of tap sets, one on the end, one on the side. We've got a vanity that will stretch. We've got a floor waste that will move, a mirror that will move, and then we have an overall width and some values in here. Okay, let's jump into the family types dialog here. Now, today we're operating entirely with type parameters, so there's no instance-based parameters. If you'd like to learn about instance and type and the differences there, we do have some videos on instance versus type. Okay, first let's just look at the basic addition function. So we have a floor waste in our project. Now, if we wanted to sort of position it in a particular place, we may want to say keep it in the middle of this space here with say an offset. We have a towel rail zone here, which is set at 1200. So to make that a little bit more dynamic, what we can do is we can come in and we can find our floor waste and we can type in, say, towel rail zone width plus whatever we like. And you can just type in the number. It will pick up the millimeters automatically. And then that's a basic addition equation there. Then you can see that updates accordingly. For subtraction, it's the same again. So in this case, we're going to do something a little bit more complicated. Let's just say that we would like, when this bathroom grows and shrinks, we would like that to be taken up by the size of the vanity. Everything else should remain as specified. So that vanity space there, we've got 1900 just defined in that space. We've got a vanity width here. Now I'm just going to type it in. We've got width, which is the overall width. Then we're going to take away from there all of the other values. So we've got the bath zone width plus the towel rail zone width plus the shower width, which will give us whatever's left over, which is 1900 in this case. Let's go back in here. Now that's this value here, and you can see that's updated the vanity. Now we can't actually apply that vanity width to this because you'll end up with an over-constrained dimension or reference plane. So you can see here we've applied that vanity width to this space. However, it's not going to allow that to happen. A simple dimension that reads back to us is fine. That actually doesn't need to exist at all. I've just left it in there for illustrative purposes. The reason that's over-constrained is because we are defining this value, and we're defining this value, and this value. And then if we were to as well tie it down, it sort of becomes a loop on itself because width is a definable parameter. Okay, multiplication. We might go down to, say, area, which is naturally our width times depth, which will give our area in meters squared in this case. For division, say we would like the mirror offset to be 1/3 of the vanity width, which is, if we have a look down here, there's our mirror offset. Maybe we want it 1/3 along. We'll go into mirror offset vanity width divided by 3, which will give us our value there. Okay, now moving down into our less than, greater than, and equal to type parameters. So that's our basic maths out of the way. Let's have a look at some area parameters. So based on some required area. So here we have our area of width times depth. That's our actual area. And we have a required area here. Now we're going to trigger some parameters based on whether the area meets the minimum requirements. Okay, so first off, we're going to have a yes/no parameter read back to us whether it's ticked on or not ticked on, whether it satisfies that condition. So with the required area no option, is the area less than the required area? Okay, and I'll click off that and you can see the box goes grey because there's a formula applied to it. And at the moment you can see that it does satisfy the condition because that's unchecked. So the question is it less than the area? Okay, so we're going to go over now and do our yes option. So in this case, it'll be the reverse. Is our area greater than the required area? We'll click off that. And again, that's grayed out, and that is yes. So these will react based on the required area, and I'll type in, say, 11, and you can see that toggle will shift between the two, like so, automatically. Now, what happens if you have an equals area? You actually have both of these unchecked, where in actual fact, area equals required area, it's actually meeting the condition. So what we need to do there is, as we mentioned earlier, we have to reverse the syntax based on a less than condition. And we have to do a not condition. So we'll go not, and then we'll reverse the syntax to be less than, and we'll close the brackets. And now we can see 10, and it satisfies that condition. Let's go 11, we'll test that out. Okay, so required area, it's not. 9, and it is satisfying. So that's now working as intended. Okay, moving down. If we would like to select our, so this parameter up here is a bar selection. This is an integer type parameter. If I go into the parameter properties, you can see this is an integer. So in other words, it can be 1, 2, 3, 4, 5, and that's it. There's no decimal places on this. Creating this allows us to have a definitive selector for our bath. So we can go 1 or 2 or 3 based on which bath that we would like to select for this particular type. Now in this case, we've selected 1, but if you'd like to lock that down, you can actually just type into the formula a direct number. say 2. And that will then mean that every single type will have, say, 2 applied to it. You can see there. Now, that's something that you could apply. You could hit apply and it'll push that change out to every type and then remove. So that's a handy way to, say, reset everything back to 2 in every type. Another way to set everything in every type is to use a definitive condition on a yes/no parameter. So if we've got, say, these tap sets here, the end tap sets, if we type in 1 equals 0, you can see that that will force that to be unchecked, and that will then apply to every single type. You can apply that. That will then push every type to be off, or you could do 1 equals 1, and that will do the inverse. Apply, that will push every type to be on. Remember to remove that to be able to let it be controlled if you want it to be. Okay, let's have a look at driving these by a parameter. So bath 1 option, bath 2 option. These are actually visibility parameters set up on 2 different baths that we have here. There's 2 pieces of geometry. 1 is this rounded option. 2 is this square rectangular type option. So we obviously don't want both baths displaying at once. So we want to put in here bath selection, which is this one up here, our integer. Bath 1 option equals 1. Bath selection equals 1. For bath 2, bath selection equals 2. Okay, so based on what is input in this parameter up top here at the integer, it will toggle between. And if it's at 0, you can see none of them will be checked. Okay, moving down to and, or, and not statements. Okay, so now that we've got these basics set up for our baths, we want to define whether the tap sets are on, whether it's an end tap set, side tap set, or no tap set whatsoever. So let's just have a look at specifying, say, the tap set for the end. Now, in this case, we're going to say that if it's either bath 1 or bath 2, then we do want the end tap set to show, so the tick box. So let's just paste in here. We've got an or condition, or bath 1 option, comma, bath 2 option. So if either of those are true, then the box will tick. So that's an or condition. At the moment, it's just the bath 1 is ticked, so it's working. If I change it to 0, then tap set bath end option will be off. Okay, you can see there's nothing there. Back to 1 or 2. That's now showing again. Okay, now let's just say side option should trigger when end option is off. So in other words, we don't want 2 sets of taps. We don't want one on the side and on the end. Let's just make a condition that states that it's not going to be the end option. So what we'll do here is we'll go not tap set bath end option, so in brackets. So essentially the rule there is that when this is ticked on, this is ticked off. When this is ticked off, this is ticked on. So it's the not condition. So let's change that now to 0. You can see that that's now applied and that's toggling between the 2. So they're mutually exclusive. Okay, and when there's no bath, we may wish to specify that there is no bath option. And that could be an and condition. So bath none option. So I might make a new parameter here just to demonstrate how this can work. New bath none option. We're going to specify this as yes, no. Let's pop that under visibility. Okay. And this is where we'll specify both an and a not parameter. So in this case, we're going to type in and then we're going to open with a bracket. And we're going to say the two conditions are that bath 1 option is not checked, and second condition is bath 2 option is not checked as well, and therefore we'll get bath none option. So that will only occur when both of those are unchecked. And you can see that that's now occurring because bath 1 and 2 are no longer checked. That satisfies the condition. It's now on. Okay, moving on to if statements. Okay, so we've got our areas set up, but maybe we would like to read that back in a more human format. So in this case, we can set up an if statement with a text string. So here's a text parameter. If I have a look here, it's a simple text parameter. We can go into the formula and we can type in our formula, which includes an if statement. So we start off an if statement with if, then we have our condition. If the required area, yes option. So in other words, if that is ticked, we have a comma, which is then if it's true, put this text in. And we put the text into our quote marks like so. So whatever's written in between there. And if not true, put this text in, close the brackets. So that's our if statement there. Okay, so we'll just run through that quickly again. So if the required area, yes option is on, then show this text, otherwise show this text. So that's if it doesn't satisfy. So in this case, it satisfies the minimum area, but if the required area was say 11, it does not satisfy minimum area. Okay, you can see how that changes there. Looking at some if statements that include lengths, we'll go up to our depth calculation. So we've got a parameter here that's going to be tied to our depth. Now it's just a basic length type parameter. Okay, so depth we're going to say is the input for the user. They're going to type in whatever they want. They're going to say 1500, they're going to say 2 meters, they're going to say 2.5 meters, whatever it might be. And then the depth calculation will actually be what is applied to the family. Okay, so that's an input, and that's what's actually going to apply to the family. Now you'll use calculated parameters like this to stop the family from breaking and to stop people putting in silly non-compliant dimensions. Okay, so in this case, we're going to do a simple if statement. Now I'll just delete the millimeter so you can see how you might type this out. Okay, so this is the same syntax as before. We've got if the depth is less than 2 meters, then make it 2 meters. Otherwise, just use the value that has been input. Okay, and then it'll automatically add the millimeters. So in other words, we're limiting this so that if someone does put in 1500, it's not going to break the family. It's still going to remain 2 meters. But as soon as they go beyond, it will accept that value. We do need to hit apply for that to show. And there it is there, and that's flexed out, gotten a little bit larger. Okay, but what happens if we want a maximum as well? Someone could put in 8 meters, which is just ridiculous. So we want to limit that to a maximum depth as well. So in this case, we're going to do a nested if statement. To do a nested if statement, we'll delete the last condition there, and we're going to continue off after our first condition. So if the depth is less than 2 meters, then make it 2 meters. Next condition, if, open up the bracket, depth is greater than, and we're going to say 3 meters, then make it 3 meters. Then we're going to go otherwise with our comma, make it depth. And then we need to close off the brackets as many if statements as we've created along this string. So in this case, we've got 2 if statements. You can make as many as you like. You can just keep going. If it's less than this, then do that. If it's greater than this, then do this. If this is on and that's off and it's greater than this, then you can do that. You know, there's all sorts of combinations you can make. And I'm going to close it off with 2 brackets because we have 2 if statements there. And now we have our resulting depth calculation. You can see that the user input is 8 meters, but it's limited to 3 meters. However, if they go 2,400, it will accept that value. If they go 1,200, it will limit it to 2 meters, like so. Okay, now that we've got all of the basics together, let's do a more complicated if statement. So we have a design outcome parameter. This is just a text-based field, and we're going to input something a little bit more complicated here, which brings together all our learnings today. So let's just paste in a formula I have prepared earlier, and I'm going to run through it with you now. Okay. So this is our design outcome formula, and it's going to look through various different things and selections and parameters and determine if we have a good design outcome or a bad design outcome. So whether it's great design or try harder. So in this case, it's an if statement. So if, and now it's going to open up with and. So everything within the brackets to follow must qualify, must be true. Required area is yes. Let's go and have a look. Yep, so that's looking good. Depth calc is not, sorry, the depth calculation is not less than 2 meters. So in this case, that looks to be true. And then one of these two, because we've got an or selection here, and we can do many or selections, but in this case, we've just got 2. Or, so just remember, all of these conditions have to be true. Or bar selection 1, or bar selection 2, close bracket. That's our and qualifier. So all of those have to be true. It's saying try harder, and that's because one of those is not satisfied, possibly this one. Let's change our bar selection to 1. Now that qualifies. And then our qualifier is, if those are all true, great design. If one of those is not true, or if that condition is not true in general, try harder. You can see how that toggles there.